I forgot to mention that this is officially my first lecture in English, so which is not obviously my native language. So please bear with me about the if in terms of this efficiency of the delivering the lecture and make you understand the concept and mathematical details. The key difficulty in the two-dimensional population is that if you want to go from this site to this site, for example, there is only one path. There is no alternative path. So there's only one direction that population occurs in one-dimensional system. But for two-dimensional system, for example, let's consider this example. For two-dimensional system, if you wish to go from here to here, you have this path or this path. If you study this lower left path, it is not occupied. So you may make the wrong conclusion that this is not connected. These two sites are not connected. But if you follow this upper right path, it's occupied. So it is they are connected. So for any of these two sites here, there are a lot of alternative pathways that you have to consider. So that is why this problem, two-dimensional problem, is much more complicated than you initially think. So that's why we deal with, I'm not sure if it will work or not. You can have this kind of thing. Oh, it works better than I imagined. So you can have these kind of things. So this case, from here to here, still there is only one path. Because there is no alternative path like this. And the key concept of this tree-like structure is the absence of such path. There cannot be any of this loop around this. So that is the main point of this. So that's why instead of moving from one-dimensional to two-dimensional directly, we first study this one-dimensional example and move on to the second simplest example of the tree structure instead of just two-dimensional structure with the possibility of non-trivial amount of loop.